In this video, we will discuss the critical angle and total internal reflection. Critical angle is the angle of incidence in the denser medium for which the angle of refraction in the rarer medium becomes 90 degree. The refracted ray travels along the boundary, as shown in figure. Derivation of critical angle from Snell's law. Consider a ray of light traveling from water, denser medium, to air, rarer medium, as shown in figure. At the critical angle, the refracted ray in air makes an angle of 90 degree with the normal. According to Snell's law, n1 sin theta 1 is equal to n2 sin theta 2. This is equation 1. Let n1 is equal to refractive index of air. n2 is equal to refractive index of water. Theta 1 is equal to angle of incidence in air. Theta is equal to angle of refraction in water. So, theta 2 is equal to 90 degree. Substituting in equation 1, n2 sin theta c is equal to n1 sin 90 degree. Since sin 90 degree is 1, n2 sin theta c is equal to n1. Therefore, sin theta c is equal to n1 divided by n2. This is the required expression for the critical angle. Now we will understand total internal reflection. Total internal reflection is the phenomenon in which all the light is reflected back into an optically denser medium when it strikes the boundary with an optically rarer medium at an angle greater than the critical angle. Conditions for total internal reflection. There are two conditions. 1. Light must travel from an optically denser medium to an optically less dense medium. 2. The angle of incidence must be greater than the critical angle, theta c. Consider a ray of light traveling from water to air. When light passes from a denser medium to a rarer medium, it bends away from the normal, as shown. As the angle of incidence increases, the angle of refraction also increases, as shown. At a particular angle of incidence, the refracted ray travels along the surface of the water, as shown. This angle of incidence is called the critical angle. At this angle, the angle of refraction is 90 degree. When the angle of incidence is greater than the critical angle, the light ray is completely reflected back into the denser medium, as shown. This phenomenon is called total internal reflection. Total internal reflection as shown in this animation.